Hello everyone. So let's just wait one more minute and then we can start.
Hello, guys.
Hello.
Good afternoon, or yeah, it's good afternoon. So I think the Reem is not going to join today. She's not feeling well, but I still saw she sent us a reminder. So thank you to her. So Talha, you are going to be leading today?
Yes, I'm going to represent today.
Awesome. Maybe I think we should
My
get
voice
going.
is clear, right?
Yes. Perfectly
Okay,
clear.
I'll start. Yep. So, uh, give me a second.
Sorry, Assalamu alaikum. Hello. Before you start, mm, everyone should know where to find the docs related to SAP, whether no matter which team or that or the team member uh, belongs to the consultation group. Everybody should know that if you want to refer the documentation, Talha, bring up the documentation, please. The URL is docs.cloud.stakater.com, and then you can navigate wherever you want.
Yep. So about the documentation, so we have this cloud documentation related to our SAP. It contains almost everything that we offer, and about after that, it also contains kind of guides. Like for example, today if we're talking about monitoring, there's a guide about alerting. You can create alerts going through these guides. It contains kind of starting guidelines on how you can monitor monitor your app or something like that. So if we go to the monitoring, so we have two stacks right now deployed in our SAP environment. By stack, I mean whole infrastructure of monitoring that contains three major parts: Prometheus, Alert Manager, and Grafana. So what is Prometheus? So just to give you guys a quick idea, so Prometheus is basically kind of a database. It's a time series database which basically collects your data and assembles it with 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 timestamps. So you basically can uh, look through your data with the perspective of time. Like for example, if I want to see what was the specific value of a variable at given instance of time, I can look through that. About Alert Manager is basically an open source tool that can work with Prometheus. So it can handle alerts that are generated by Prometheus, and it can, kind of throw those alerts forward if you configure it with some other app. For example, if I want to throw my alerts to Slack, I can do that with Alert Manager. And then there's Grafana. So Grafana is basically a visual dashboard for your Prometheus. It can read matrices data from Prometheus, and it can visualize. You can basically visualize those. Uh, so that was just a quick guide of the parts that we have right now. So we have a small tool, not very small. So this is Ingress Media Controller. This basically this is a part of our monitoring stack. So IMC basically watches for any new ingress or route and creates a liveness alert. Basically, it creates a alert in Uptime Checker. For example, right now we are using Uptimerobot. So it what it does is like it takes the definition of the route and it creates an alert. It creates an alert object in that third party platform. for downtime for Uptimerobot, it creates an entry in Uptimerobot and configures it with our some notification. For example, right now we are using Slack, so it configures it with Slack, and we can kind of if that route goes down, we can know if that route went down or not, and it will generate an alert for us. So at the moment, we kind of give me a second, guys. Sorry. So right now uh, we have a foolproof solution of monitoring that we offer with SAP. So we offer all level of maturity levels for our monitoring. So as you can read, for so basic level, this is uptime green monitoring. So what does it mean is this is just a basic monitoring that, for example, your app went down for some reason, you'll able to know. So apart from that, of one level up, you can also know about the resource usage of your app, for example, CPU, memory. Uh, then after that, you can have uh, another level of monitoring. So it basically is this monitoring is around your app. For example, you want to know about the response times, the number of requests your app is getting, and all that stuff. And then third one is, for example, custom monitoring. For example, you want to add some more, as you expose some custom matrices through your app, and then you want to add some level of alerting on that. So for example, your app is kind of integrating number of users, and you want to know like how many users, if your users are more than 100 at the moment, you want to know about that. You can have a custom monitoring on that level as well. So
Maybe it would
sorry.
be good if you go back to that picture, Tala.
Mhm, mhm.
So if you open up Uptimerobot, we can show them level 0. So then it would be more, so that everyone understands, okay, this is what we mean by level 0. Um, so it would, yeah. So basically, this is level 0, means that we use Uptimerobot, and all it does is it just call your health endpoint, and if it is red, it means it's down. If it's green, it means it's up. And
So just to give you an idea, I'll quickly, let's say if I open this up, right? So what it is doing, it is basically hitting this URL, and it is checking for 403. If this keyword doesn't exist on this URL, it will generate an alert. So this is done by IMC. IMC created this entry. You can manually do this as well, but obviously IMC is taking control of everything. So this is, yes, as Rishi said, this is level 0.
yeah, so this is the basic. And if you open up the Stakater organization, we can tell them what IMC is. Like if you open up the GitHub Stakater,
Yep.
so people can get an idea who are not familiar with our tool called IMC. Yeah, you can just click. I think it will come up. Yeah.
So this is our tool, Ingress Monitor Controller.
So this guy looks into the routes, and if you would like, then it will just create a check for you in the Uptimerobot or the tools that we support in this. If you go down, I think we support a couple of different tools.
Yep. So this Uptimerobot, ping
Status
cake, uptime,
Updown.
application, and you got a relevant configuration guide as well for each platform.
And in the SAP, yeah, go ahead.
We also have we can also configure settings in Kibana.
Angela, your voice is echoing.
Okay, I think it's okay now. Should be okay. Right?
Yep.
Yeah. Okay. What I was saying is basically we can also configure some uptime status in Kibana as well. Why do we go for the external services for like Uptimerobot? Because Kibana is managed by us, and it's better if we just remain in the platform and and use as less as possible external services as well. We have called uptime in Kibana. We can configure a dashboard as well that monitors the same thing. Uh, so what are the benefits that Uptime Robot gives and not other tools can give us?
How will Kibana send you an alert, Hanzala?
Uh, it could send via alert manager or other thing. I think it has it do have it do have, I think, settings for the alerts as well.
Okay,
It can
so
send via.
the feature set you are describing right now, the feature set is basically some, I think, comes with the XPack module that is actually a paid solution.
Yeah, expect uptime module.
I'm not sure with the exact module, but Kibana in our infrastructure is basically dedicated towards the logging infrastructure, right?
Yeah.
Yes, it can ingest matrices as well. Elasticsearch can ingest matrices, but we are keeping our service as close to what OpenShift does. So we have two separate stacks for logging and monitoring. So, for example, if logging stops working, if we go with your approach, if we do not decouple those both things, right? So if logging goes down, our matrices will stop generating alerts. So we would never know if logging is down because it will take the alerting system with it.
When I say a matrix, it means, I mean, when it's matrix, of course, these are not Prometheus matrix. These are just, they just send a traffic
Yeah,
and then it.
so Angela, I think the point here is that if Kibana goes down, then we will not know actually. So the reason why we use a third-party service is just to have an extra layer of defense that we are relying on another system that we do not manage will actually notify us if something happens. So that is the basic reason why we use a third-party system. The why we rely on a third-party system is just to
Yes,
get an
also
extra assurance.
I think
yes, also they specialize in it. So
Yeah, I think yeah, it's more like the extra assurance that we are trying to get for ourselves, I would say.
yeah, but I think if we can get the
Because
same feature.
alert manager can already give you all the alerts that Uptime Robot will give you actually. So we don't even need to use into Kibana and the logging stack. We can get all these alerts from alert manager, but
Okay.
we want to have an extra layer of defense where we are relying on a third party that we don't manage to notify us. Because if our alert manager or Kibana silently stopped working, let's say, we will not know actually, but this guy will tell us that okay, I can't reach your health endpoint. So it's a very basic service. It looks very simple, but in our experience, I have seen it's a very powerful service. Like it will just do a health check. Okay, is google.com up? It looks so simple service. Yeah, it is so simple, but it's a lot of value. So that's the reason. Okay.
Is it a false sense of security that okay, if because we manage that service, and if that managed service goes down, we can't get alerts. If that is a thinking we have to keep, then the vault can go down and we can lose all the data. Any of the services can go down and all the data. So we have to trust what we deploy, right?
No. We are
So
trusting. We are trusting. It's just like extra layer of alerting. So we're not trusting. We are trusting it. We are trusting everything we deploy, but it's just an extra layer of I would say alerting we have. So we don't configure health endpoints in Alert Manager. We configure them in a third party service that's outside. So
okay,
that's it. So we're not trusting. We are trusting. It's just like we have deliberately used another service for the basic health check endpoints. Up
okay.
and down, nothing else.
Got it.
Yeah. Okay. So Angela, so this is level
so
0,
the
guys.
next level is
Yeah.
so the next level is so the next level is let me see.
Can you open Forecastle?
Yep.
It'll be much better to, you know, yeah.
Forecastle
Of any
for
child cluster. Maybe you can find there actually. If you open the parent Forecastle, I can guide you.
so the forecastle is Yep.
Yeah, then you can take to the infrastructure monitoring Grafana. Yes. Yeah. Will it load today?
I hope so. Yep. So meanwhile, we can go through. Let's say. So let's say if I. So this is just. Let's say if I go to Valero, right? We have this tool Valero as well. So the one level above monitoring is basically resource monitoring. So Grafana will show same kind of stats, but we can also see those stats in this hours. Sorry.
Instead of Grafana, just show them the matrices on the OpenShift console dashboard. Go below
Hmm.
monitoring dashboards. You can see those exact dashboards here, most of them, if it loads.
I think we got lots of data. So the time range is 5. So let's say
Go
if we
to
go
yeah.
to
Show first
pods,
cluster.
right?
Show first cluster, then nodes, and then pods.
So so if we go to the cluster, this is the whole cluster utilization. So right now we have this, it's showing us like we have 21 percentage of CPU utilization, 21 percentage of memory utilization, memory request commitments, memory limits. So these are all the stats that are picked by the monitoring. So we can also see individual CPU usages that are being scrapped. So there are like lots of pieces, lots of objects that are being monitored for CPU. If we change our dashboard to let's say pods, so so it shows cert manager operator uh, in this namespace. If I change this to let's say something like how much of monitoring, so it will show me like, so this is showing like alert manager is using this much memory,
Where
and
does it
alert
show?
manager 2 is using this much memory. Sorry.
Does it show for the customer application as well? The
Yep. So,
customer application.
so for customer, there's this, so there's this another monitoring. So this is basically for the monitoring of. So this is these matrices are coming from default OpenShift monitoring. So this will also show the stats for our tools as well. But
Yeah,
for
but how did
customers
you
workload, we
configure?
have to go to. So for that, we have to go to our second workload monitoring, which is workload monitoring. So
Yes. And how did you configure? How did we configure that which namespace it has to pick? Because
so
it is
that
picking
is
up.
uh-huh.
Yeah, go
Sorry.
ahead. Yeah, I
The
was saying because
default
it is picking from a
the
Stakater
default
namespace.
monitoring
I
will
think it was
basically
somehow.
monitor all the namespaces, Hanzala. The default
Yeah.
monitoring will basically monitor all the namespaces, but the alerting mechanism is separated because we want to increase the maturity of monitoring as Talha described earlier. And in order to achieve that, there are some limitations that are put in place by OpenShift itself for the infrastructure monitoring, right? And if we want to extend that maturity model, if we want to like um, like mature our infrastructure, then we had to separate out uh, the whole monitoring stat for specifically for applications, so we have more agility and flexibility towards monitoring the custom application or the customer's applications. There are some limitations in this stack which basically prevents us from using a single monitoring stack.
Yeah, but what I was saying is, how did we configure that the infrastructure monitoring has to pick metrics from our namespaces, because something somehow it must be configured by us, because it is watching our namespaces, not OpenShift default. So how did we configure that this one has to be watched by infrastructure logging? Did we create service monitors?
No, so basically, this is what we're talking about here is the CPU matrix, like the matrix of CPU and memory. They are scrapped from the kubelet, and Prometheus is we have a node exporter running, which is exposing the matrix from the kubelet. So that's why we will get matrix across all the pods, across all the namespaces. We can get all that information. So Talha, if you click on the link that I sent you, is for the I can explain you, Talha. I can explain you that, Hanzala. I can explain you. But this is, if you look here, guys, this is the level 1. So this is right now our OpenShift cluster running for Coop customer, their production cluster, and Bitala prod is one of their namespaces. And here the developers can come and they can see the CPU and the memory utilization of their application. Okay. Yeah. So that's level 1 actually. So now we can look into level 2. Can you open up?
I'm not sure about level 1 actually, because like I had a question on level 1, because you are saying that it by default takes data from all over the cluster, from all of the pods.
Yes.
It by default.
Yes.
Because as far as I know, in Prometheus we have some targets and we somehow configure those targets.
Yeah, but that's a service monitor thing. So that's another thing, So the service monitor will only expose your custom metrics. You do not expose your CPU and memory from those custom metrics. So those service monitors are for your level 3 actually that you are talking about. Hanzala?
But can you go to the Prometheus of level 1 monitoring actually? Because if there's a Prometheus, then Prometheus must scrap targets from somewhere.
Yeah, but but this data that you're looking into, that is coming from kubelet.
Yep.
That's what this is coming. Sorry.
Directly via kubelet to Grafana?
No. Prometheus is picking the data from kubelets.
Okay.
So this is the basic, we call basic metrics like CPU, network. So that data is exposed by kubelets running on each node.
Okay.
I have another picture that I can show you that, so that will explain explain that. But this is not the custom metrics. This is like the basic CPU, networking, bandwidth, and those kind of metrics that you see here. And they are exposed by metrics or by kubelet running on each node.
But if I look at the targets of Prometheus of infrastructure monitoring, that is level 1, I see there are some targets configured. They are actually picking up data from the kubelet and everything.
Yeah, so, you will see that they're picking from kubelet. Yes, for each node you will see one kubelet target being picked up by Prometheus.
Yeah. So is that configured by default, these targets? Like
yes.
If you go to this.
Yes, by default they are done by this default monitoring stack. It scraps all the Prometheus. It scraps all the kubelets.
Okay. So these do not come from the service monitor, as contrary to the level 3 monitor.
Yeah, exactly. So this is not service monitor. No. This is that's why it's called level 1, and why it's called the CPU and memory. So if you open that diagram again, Talha, please.
Yep.
Peripheral monitor.
There we are.
Yeah. So this is says CPU and memory for the pod. So that's not your service monitor.
Yeah,
Make sense?
because
Yeah.
yeah, because you know what Service Monitor does is basically Service Monitor alters the configuration of Prometheus, which is Prometheus.yaml that is mounted, and it is mounted on all of the Prometheus. So because I see some configuration that is also in the Prometheus that I can share the link as well in the chat, in the infrastructure monitoring. And what you're saying, it is coming by default, so it is not coming by Service Monitor. Somehow it is the default configuration that is put by OpenShift. Okay.
But no, I'm saying that this data is coming via the kubelets, So that's what I'm trying to say. This data is coming via the kubelets,
Yeah, I
And
was
how
trying
it,
to,
yeah,
how Prometheus is scrapping that. I was just trying to understand actually.
yeah. I have a picture that I can show you. I think once we go through these levels, I think maybe Talha will
Sure.
present, but I can show you a picture that explains
Just
how. Yeah.
sorry,
Yeah.
sorry. Just to give you a quick idea, basically kubelet is the service that is responsible for running containers on
Yeah.
Kubernetes node or a host, right? So the kubelet has basically idea of every container, the amount that is committed, the amount of CPU and memory that is committed, that we call requests, and it is also cognizant of the limits that we assign to that container. And
Yeah.
so kubelet also knows what amount of CPU and memory utilization is, what is consumed by a specific container. So all these matrices are basically exposed via the kubelet service, and Prometheus basically uh, gets that from that kubelet service. So all the pods, irrespective of which namespace they deployed in, right? So if you scrape a kubelet on a specific node, all the containers running on that node, you can basically get the matrices out for them.
Yeah.
Does
Okay.
that answer your question?
Yeah. I understand. Like I understand the good thing. Yeah. Like of course. I think you can carry on session.
I think it's going
Yep.
to be good. Here you can open the micrometer, and that could be the black box or texting. The micrometer, and yeah, Bitala prod. So you look here now, you get more level of matrix. Like these are like a JVM matrix now, and you cannot see the JVM, the Java Virtual Machine matrix is from the kubelet. So this is now there is an endpoint for this particular application that is exposing the internal matrix of the pod that Prometheus is also scraping. So here you can also see the CPU and those things, but they're not coming via kubelet, Then they are coming via the service monitor that this application is exposing.
And what are the advantages of separating customer workload and infra workload? What are the advantages of that? Is it because of the limitation, or is it because we want to do that way?
No, the thing is
Custom
that
monitoring.
when we do the custom monitoring, one of the major reasons is the Grafana dashboards. We cannot modify the Grafana dashboards that come in the default monitoring stack. So that is the biggest limitation. If we want to add custom dashboards, we need to have another Grafana instance. That's one of the reasons.
And is that how OpenShift recommends that as well? Because OpenShift must have awareness of this limitation. Is that
No,
how
they have not released that feature yet. Hopefully in maybe next what you say release it will come. They don't have
Okay.
this. Unfortunately, they're always lacking. So when we started working with Prometheus with OpenShift 3.11, they had no Prometheus actually. They didn't have even default monitoring. So we used to run Prometheus ourselves. So Red Hat is always behind a bit from what the market is using, and then they add those features piece by piece to OpenShift. So for example, this default monitoring, there was nothing in 3.11. So we have still customers where this OpenShift, we are running Prometheus ourselves. It doesn't come as part of OpenShift. We do not get any support. So that's how Red Hat is typically catching up, I would say, with the feature sets.
And we deploy the whole stack like Prometheus, Alert Manager, Grafana as well. Couldn't we just deploy Grafana and use the same Prometheus and Alert Manager?
Could we? I don't know.
Okay.
I don't know. Maybe Sama, do you, and Talfa, do you know?
Sorry, can you repeat your question, please?
Yeah, I was saying that we deployed separate stack like separate monitor, separate Prometheus, separate Alert Manager, and all that for customer monitoring as well. Right now we have a limitation that we cannot add Grafana dashboard in the current Grafana that comes from Openshift. Couldn't we
Yeah.
just install Grafana ourselves and use the Prometheus that is coming from the Openshift?
Yes, we can do that. We can do that. But there is a OpenShift recommendation and OpenShift way of monitoring application. So this tag that you're looking right now, not this one, this is workload. The Prometheus that comes with as a part of the OpenShift operators by default, that is strictly dedicated to monitor OpenShift itself. Uh, by itself, I mean the OpenShift namespaces, right? And OpenShift recommends that if you want to monitor your workloads, you should have a separate stack. So this is by design and not some like this is opinionated, and that's how they do it. So they have like an they have the inbuilt default way of monitoring OpenShift itself, which is
And if they
uh,
recommend, do they have the reasons like why do they recommend what are the advantages you get for the separate monitoring?
yes,
What are
because developers do not concern uh, the matrices of the cluster itself. As a tenant, if we talk about SAP, as a tenant, you do not want to see the nodes utilization, whether the monitoring is working, whether the logging is working. You expect those because you're a tenant, so you should not see those dashboard. By the principle of least privilege, you do not need to know if the nodes utilization is high or low. So they recommend that a separate stack should be built, and only developer relevant matrices should be added to those specific workload monitoring stack.
and it means there should be a separate stack for the tenants as well. For each tenant, there should be a separate monitoring stack.
For true multi-tenancy, yes, that's the recommendation, and that's why we have Michael working on the Grafana operator, and soon we will have like multiple Grafana dashboards specific to those tenants, so they can only monitor and see their application.
Okay, so OpenShift recommends separate because there is no mechanism of access management in Grafana dashboard. That's why they recommend to separate out Grafana dashboard.
Yeah,
For each of
Yes,
those,
Prometheus doesn't have any such mechanism. So Prometheus doesn't have any role RBAC in itself, So it's a
and
common
developers
fact.
might want
does not need
developers
to
might
have any,
look
because
for
if
they
you
go
want
for
to see
graphs.
matrices, you can restrict the RBAC on those matrices, because you can put the RBAC system where you want to visualize those matrices, like on Grafana. So Grafana by default does not have, but you can isolate. We have Grafana operator, so you can have like individual custom deployments of multiple Grafanas, and you can set up your dashboard and then just have the Prometheus as the default data store.
You're saying is when so Grafana operators has the access management system like you can just only look at your dashboard and you don't have access to others. Grafana operator has this.
Yes, you can say yes. You can have multiple Grafana deployments for multiple tenants.
Yeah, but that would be
And
separate Grafana deployment, Hansala. Don't confuse that. Separate Grafana deployment, not one Grafana, multiple dashboards.
Yes.
okay,
So
also
that's
separate.
Sama is saying separate Grafana deployment with the Grafana operator.
Okay, so it means different Grafana with the same Prometheus, and in
Does
different
not
Grafana.
have it does not have a refined RBAC. It has a basic RBAC of view editor admin. Michael can comment on that better, but not fine-grained access control. That's why they
Okay,
built the operator to have multiple Grafana deployments.
Simplify the management, you can say. So I think
so just because of the access thing, we should separate out the stack for monitor, for customer monitoring and for infra monitoring. It's just because of the access thing.
yeah, it's also access and the possibilities of customizations. So there are two things actually. So I think I was reading myself right now because I had this question to myself like a week ago. Would you mind taking if I take over screen share, Tala?
Yep.
It's okay. Okay, yeah. So I was like reading myself, like a week ago, and I shared the wrong screen. Which screen do you see my emails or
Monitoring stack.
monitoring stack? Okay. I thought you saw my emails. So I was, I had the same question last week for myself, like, okay, why do we have two separates? And this was the conclusion that I remember I documented. So we have two alert managers. One alert manager is running in the OpenShift monitoring alert manager to forward all the alerts from the like OpenShift owned and the Stakater owned namespaces to our PagerDuty service. And then we have a Stakater workload monitoring alert manager. And we cannot change the default alert manager configs on the fly. So therefore, we have to use a dedicated alert manager for it actually. So it's like the limitations we have on the alert manager that comes as part of OpenShift. So remember, the default monitoring stack is a part of OpenShift installation. So if that does not succeed, OpenShift installation fails. That's very important thing. So they ship Prometheus, the default Prometheus and default alert manager as part of OpenShift installation. So they are like, if they don't succeed, OpenShift installation can also fail, that, okay, monitoring stack is not coming up. So, and they have then some limitations. They do not allow us to modify the things, So we cannot modify the alert manager configuration. So we have to run a separate one.
But when we set up alerting mediums like Slack or PagerDuty or whatever, what do we do? Don't we modify the configuration?
Yeah, but we just modify the default monitoring stack once for ourselves, But if each tenant wants to start modifying the alert manager to add their channel, someone wants to use email, someone wants to use Slack, so we cannot support modifying the default the monitoring stack. We do it once, to alert our setup. But with the second alert manager, we allow them to modify on the fly. And same holds true for Grafana. So if Red Hat takes away those two limitations and allows, okay, you can define your own alert manager config and ship it, and you can define your own Grafana dashboards and ship, then yes, we will not need to have a separate monitoring stack. Okay. And to answer your previous question about how the monitoring of the metrics work, this diagram is very important for everyone to understand. How do we get the CPU metrics and how do we get the node metrics? So if you look on my left side, here I represent the nodes. Nodes can be workers, masters, or infra. On each node, we have something called kubelet, which is running. That's a core component of Kubernetes. And within the kubelet, there's something called cAdvisor. This thing is from Google, they're open source. And this guy is responsible for collecting all the metrics from the containers that are running on a node. So this guy is scrapping all of those metrics, like network metrics, like CPU, memory. He is scrapping them out. Look at this line, collect container metrics from the Docker engine. And then Prometheus is configured to watch all of those kubelet, and it is scrapping the metrics and storing in a time series format in itself. So it's scrapping all. So that's why you will get all the containers that are running in the cluster. You will get this basic information about them. the CPU, the memory, and everything, because they are exposed by the kubelet with the help of C advisor. And then we have another thing running on each machine, which is called node exporter. And this guy is collecting the operating system level metrics from the Docker host, and it is exposing those metrics. And then they are also being scrapped by the Prometheus. So Prometheus is scrapping 2 services on each node level. One is the kubelet, and other is a node exporter. And then those metrics end up here actually. And then you can do whatever you want. You can show them on Grafana. So the way we showed you guys, like just a while ago, you could see the CPU, the memory. They come by default with Openshift. We don't have to do anything. When you install Openshift, you get those metrics. And then you can configure your alert manager based on those metrics. If the CPU goes beyond this, the memory goes beyond this, send me the alert. Anyone has any questions here, please feel free to ask.
Yeah, Rashid, one more time, like what is the difference between these two collectors? One is like a kubelet collector.
Yeah, so
like
the node exporter, as the name says, it will expose the node level metrics. Okay, how much the node CPU, how much the node memory is being utilized right now. Node's network, And the kubelet is giving you the container level granular metrics, how much this container is using,
Okay.
So we have different dashboards to represent the different picture,
So Rashid, is that mean so these one come by default with Openshift installation?
Yes.
Okay. So that means like we are not exposing any endpoint through our container. So this one is like by default.
Yes, exactly. Okay. So you don't have to expose anything from your container. You will get these metrics because kubelet is gathering those metrics from Cryo, the runtime engine. So it talks to runtime engine, because the runtime engine, be it a Docker, be it a Cryo or a Rocket, they expose these metrics, So C advisor is getting, so you don't have to have any endpoint on your container to expose it. So they come by default.
Okay, so that means like in the pyramid, we saw that like there was this stack. So we are like in the middle of the stack. Like this one is like core monitoring.
Yeah, that's a core monitoring. The CPU and the memory, the level 1, that's what you get by default when you install Openshift. You don't have to do anything. The level 0, you don't get by default. Stakater installs IMC, configures the Uptimerobot, and then it works.
Okay.
The level 2, which we were showing you right now with the micrometer, you have to expose an endpoint. Otherwise, we cannot get you those metrics.
Okay.
Because the JVM metrics, you have to expose. The container has to expose the JVM metrics. Like, okay, this is my metrics.
Okay.
But my question was basically how actually it describes from the kubelet, because as far as my knowledge is concerned, Prometheus sent HTTP request to some endpoint and it describes data from that endpoint. Does Prometheus have access directly to the node?
Yes, so it uses the TLS, it uses the certificates mechanism that comes built in, that it talks to these nodes, Prometheus is able to reach them out and be able to access them,
Okay, so Prometheus container send a request to node internal IP and at particular port, and it's data from there.
Yeah, because it's exposed as a process, as a service running on the nodes, So it does use the internal IP, find the process, because these things are not running as containers. Is kubelet running as a container? No. So they're not. Well, this is a container. Node port export is a container. Kubelet itself is a container, yes. So they are being exposed as containers itself, and then they expose these metrics. But the whole communication comes bundled in with Openshift installation and this Prometheus installation. So we don't do anything ourselves, So when you add a new node to the cluster, we don't have to do anything. It automatically starts scrapping.
Okay. So it means that it has access to the node endpoint, and it sends request to the node endpoint at particular path, and with the certificates and all that, and then it scraps data from here. Okay.
Yeah, exactly. So it has to have because Prometheus is a pull-based mechanism, It goes out and gets the data.
Yeah.
Okay.
But but
Yeah. What's question, Hadla? You had a question? Or
no, I was just looking at the Prometheus configuration that how does it scrap from the kubelet
yeah, if
metrics?
you read the Prometheus config, you will find the basic configuration. You know what it scraps. You know, so it's going to be a long configuration of Prometheus that you can see, which defines these how it does it. You know, yeah.
Yeah.
But it's very important is to understand this. Okay, how these metrics are coming. You know, and it's also very good to understand how the communication happens. But in this case, it comes as part of OpenShift, so.
Yeah.
We don't go that deeper, but previously we have been setting it up ourselves, you know. So but okay, any more questions on this one, or it's clear now?
Yeah, it's great.
Okay, good. And then this was another diagram that is also good. I think it's pretty old, but it works, you know. If you see Prometheus is running in the middle, and this guy pulls metrics from the Kubernetes API, it pulls metrics from the Kubernetes nodes, and it pulls metrics from our microservices, you know. Yeah. Okay, handing over to back to Talha, you know, so to continue on the levels, you know. Yeah.
Can you guys hear me?
Yes.
Uh, so I'll quickly go back. So you guys get the idea of this levels that we have right now. Uh, yep. So I'll open up this image to. So you guys have like so on and off you guys happen to work with monitoring in our SAP environment, so it's better that you guys have a basic idea of like how the monitoring is working right now. So this diagram explains it a bit. So we have three types of namespaces. One is our namespaces, Stakater namespaces. One's our customer namespaces, and the third one is OpenShift default namespaces. So regarding that, we have two monitoring stacks. The one monitoring stack is basically OpenShift monitoring. The other one is Stakater workload monitoring. So workload monitoring is basically a stack monitoring stack that we deploy and manage ourselves, and the OpenShift monitoring is handled by OpenShift Red Hat team. So let's say if we talk about operational analysis, everything that is all the matrices, all the targets are being scrapped for OpenShift analysis are for default OpenShift monitoring. Prometheus scraps those. You can visualize those matrices through Grafana, and those and all the alerts that are generated within Prometheus that are forwarded to Alert Manager. And Alert Manager, at the moment, our alert manager is configured with PagerDuty. PagerDuty. There is this specific service entry for each of the customers cluster within our PagerDuty. So that is how we separate out the alerts for each customer, and then that PagerDuty is hooked with our Slack. So each customer got their own Slack channel where uh, the notifications are forwarded. So same as that, customer workload monitoring. There is no default uh, third-party alerting that is configured with Alert Manager here, because that is something that is uh, used on demand. So let's say if a customer, so this is something that is already deployed, and let's say a customer wants to monitor their app, they can come in and they can define their their custom service monitors. Let's say if they define a custom service monitor that will be picked up by Prometheus targets, they can check their matrices, their data through their Grafana, and then those alerts can be forwarded to Alert Manager. They can configure Alert Manager to however they want see fit, and they can forward their logs to whatever medium they like. So
Talat,
this is the basic. Sorry.
we can simply send alerts to Slack as well. Why do we use PagerDuty? Like, what are the advantages of using PagerDuty as well? Because we can
Yep.
directly send.
Mhm. So PagerDuty adds extra features right now. So let's say if we basically so the major benefit that we get from here is we get every incident there's gets created with a new ticket. So let's say if let's say there was this tool Nexus, it went down, right? So it went down. It will create an alert through Prometheus, and let's say if it creates an alert, let's say if your Nexus pod is crash looping, right? So it will create
Yeah.
an alert through Alert Manager, and there will be a ticket created within PagerDuty within that specific service directory of that cluster, and that will be assigned to any SRE guy, and uh, against that ticket, an alert will also be generated onto Slack. So you can basically so only Slack is not enough for that purpose, because
So
you have to kind of
what does it mean
sorry.
by ticket assigned? What does it mean
So
by
let
ticket assigned?
me quickly open up PagerDuty. It will be easy to show. So let's say we have this alert generated triggered in our Venero cluster, right?
Yeah.
So if I go to service directory, I can see all of our clusters listed here. So
Okay.
these are some different clusters. So if I go to, let's say, uh, our Venero cluster, so if I open this specific cluster, it will show me all the details, all the triggers, all the alerts that were generated, that are being triggered, that are currently open, and that are currently that are resolved. So you can basically go back in time and see what was down and how it was resolved and all that stuff. Uh, sorry. Also, about assigning, this basically means, so you can see here, like this alert, this specific trigger is assigned to me, so I'm the one who should be fixing this. If you go back, you can see there are these few alerts that were assigned to Tehrim. So this is basically these alerts are basically incidents are basically assigned to the person who's on call. So we have this call every week. Every person is on call, and he's there to fix the issues that are being generated. So
Okay.
is your question clear?
Yes, and
Sorry.
they get email, like the relevant person get email that you are supposed to solve this issue.
So email is something that is configured by default within this. So yes, I'm getting emails as well.
So good
Okay.
thing is
So
that
this is a since
PagerDuty
the
can basically have that basically the mechanism that assigns a ticket to a specific person and all the relevant details along with it that is forwarded to PagerDuty by Alert Manager. So
but
uh,
can't we alert manager to Slack directly, alert manager to anybody directly? Like we can say that okay, if this alerts come, send this to this email and this person. So we can do
yes,
that with the
yes, you can do that, but how there has to be a central dashboard where you can track all those incidents.
alert manager dashboard tools as
Then
well.
Alert Manager does not have the mechanism to assign that specific incident to a particular person.
Also, Alert Manager doesn't really maintain the history of everything. So
But incident is for suppose that I can configure the alert if this alert comes from this if this alert has this configuration, then send it to that person. I mean assigning means notifying that particular person, right? So if for suppose if X alert come, I can forward it to Y person. I can do that with having a
Yes,
central.
and you can do that. You can write custom logic, but let's say somebody leaves or somebody is added to the team, I would have to change across every service. With PagerDuty, I can just add that person to the PagerDuty, and that can be taken care of within minutes. It has the rotational, the on-call rotation as well, but that is not relevant here. We are uh, almost the time is over. Talha,
This
I would.
last question, it's about not about the feature, it's about how we configure that feature. So with PagerDuty, it's easy to configure that particular feature rather
Ye-
than uh, rather than alert manager.
Yes,
Is that
then
a
we have
particular?
the integration with Jira, and Jira tickets can be created automatically as well. So yes, we have that capability in PagerDuty. That's why we prefer it, and it's a general. Uh, it's a general practice. It's like accepted by the community, and most of the it can basically scale very well as compared to your custom logic. Talha, I would ask you to go through your little demo if you have something.
Yep. So time is almost up, so I will try to be quick on this one. Yep. So I have a Prometheus open here. So if I go to, so you can see uh, something that was that Rishi was talking about, service monitor, right? So for service monitor are something that were defined by user. User mean user means something not comes by default within OpenShift cluster, right? So we have this service monitor Valero. The service monitor is there. So this service monitor is basically picking up matrices, custom matrices from within Valero. You can see that here. So this is up, right? So this basically means the state is up. Let's say if something happens to Valero, in this, let's say this pod goes in crash loop, this matrices state will go down. It will be marked as red. So just to so how I can, let's say for example, if I wanted to kind of know about the state of OpenShift Valero, this basically also comes with the expression of so how can I kind of generate an alert against this, right? I want to just generate an alert against Valero container itself. So for that purpose, I can use a Prometheus rule. I already had defined one rule. So this rule basically says up container Valero is equals to 0. So this basically tells me if the container is not running for Valero, it should generate an alert. So right now, I don't see any alert against this demo rule. To make it quick, one means uh, I I'm redundantly asking it to generate an alert. So there's no uh, alert against this rule in Alert Manager. If I go to my rules, you can see this rule is submitted here. So it says the state is okay right now. Reason is the state of this matrix is 1. So if I'm about to add an expression, so this expression is basically something that you have to define. So this basically totally depends on the type of matrix that you're trying to monitor. It can be anything. Right, this is just a simplest example right now. So if I have changed it to something that is giving an output, it should create an alert for that. So let's say if I go back to rules, I updated that rule. It should reflect in Pit. Meanwhile, that is happening. We have something called pod monitor as well. So there's this service monitor that basically monitors the service, that is the service Kubernetes service that is in front of your app. And if we, so pod monitor is something that is directly hooked to a pod. We have one pod monitor that is running configured in our namespace configurator. So this is a pod monitor that is configured to check for the pod of namespace configurator that is also shown here. So if you can see all the targets here in your target tab. Let's say if I'm about to write namespace config operator. So you can see here. So this one config pod monitor is submitted for to Prometheus, and it is being scrapped all the time from through Prometheus. So you can see here. as soon as this demo rule, I changed it to something that is arbitrarily triggered. So this gives an output and alert is generated. Uh, so that alert manager is configured with.
Show that in the
Mhm.
pager duty, please.
Yep.
So this
So
alert was
as
generated.
soon as the alert is generated through this alert manager, let me just reload this one. So you can see there's this one alert generated demo app. This is also generated in Prometheus. So this one is being generated in Prometheus. That is being forwarded to alert manager. The alert manager then put it through the pager duty. So you can see this incident. There is this incident created in pager duty. It contains all the labels. So the some labels that we define are here. For example, we define severity critical. Everything else is being populated on the fly. So let's say this is alert name is demo app. This is the instance that is the IP of the pod. Then it's telling about the namespace, which namespace is coming from. It's telling about the pod, which pod is it is coming from. So now this alert is basically gone back, pushed to Slack channel of the specific service directory. So you can see here, this is being triggered here. So if this resolves automatically, it should resolve in PagerDuty as well. So let's go back and
Uh, Talha, just
sorry,
just a second. Can you go back to
sorry.
the rule, Prometheus rule?
Yep.
The reason why it took more than usual is that uh, is because on line 30 it says for 1 minute. So the alert will fire if the expression that is described in on line 29 holds true for 1 minute, right? So maybe there was this one dip, right? One time dip in the expression, it became false and then it became true again. So that will not count. The alert will fire if that this expression holds true for 1 minute straight. So it will not just
Yep. So
instantaneously fire. It will monitor it for 1 minute and then generate an alert.
yeah, for reason for that is something that sometimes you want to configure your app to not just give you, as Osama said, not give you alerts just frequently. So let's say there was this glitch in your app for like even for a millisecond, you don't want to know about it uh, if it's not persistent. So that is why that is something that we have this tag for. So it should resolve in a minute now. So that was it for the demo right now. So you can see it is being resolved in our Prometheus. It will resolve in Alert Manager now. So much should it take time to resolve on our PagerDuty side?
Mm, not really. Can you do a refresh for Alert Manager?
Refresh for PagerDuty. So this is not being so this resolved on Prometheus and Alert Manager side. So I think it should take a
Yes, it
minute more
will
to
take.
resolve it on
Yeah,
PagerDuty side.
it might take some time. Yeah,
Yep.
will happen.
So this resolved on its own. So that is something. So that is a quick demo about how the monitoring and alerting flow is being done within our SAP and within our SRE team. So yeah. So purpose for this demo was to for you guys to give an idea of how the monitoring is working. So you guys, if you have to work on it, you guys have like a proper understanding for it. If you guys have any question, you can let me know. Yep.
Any questions, guys?
I guess not.
Yeah, okay. So, Talha, thank you for this whole session and for the demo. And we'll see you